This lesson is declaring and working with variables. The objectives for this lesson are to learn what is a variable, the rules for naming variables. We'll do an overview of the built-in .NET data types, talk about how to declare variables, see the default values of each data type that's assigned. We'll talk about an overview of the object data type and using nullable types. Let's get started. Now, I'm sure you already know, but what is a variable? A variable is simply a value that is stored in computer's memory, and you can change and retrieve that value. There's two different types. There's value types. These are simple values like integers and decimals that are stored on the computer stack. They're less memory intensive and better performance than reference types. Now, reference types are things like objects. So you're going to build classes later on in this course, and we'll see about how we create objects from those classes. Now, reference types are stored on the computer heap. Now, when you name a variable in C#, you must begin with a letter or an underscore. After that, you can have any combination of letters, numbers, or underscores, up to 255 characters. Now, I do have some standards documents that I've created for naming variables, methods, all sorts of things. You can find them on my GitHub. So if you go to github.com/pauldsheriff/tips/tricks and scroll down, you will find my standards documents. .NET provides us with many built-in value types. Now, this is the variable that holds the actual data that is stored on the stack, and they consist of bool, byte, sbyte, character, decimal, double, float, int, uint, nint, nuint, long, ulong, short, and ushort. We also have reference data types. This is a variable that is simply a pointer to the area on the heap where the data is stored. So these are things like objects, strings, and the dynamic keyword as well. Now, there's also a thing called the structure data types. Now, this is a variable that holds the actual data, so it's kind of like a value type, but it's also kind of like an object. There are properties and methods on these. So, for example, DateOnly, DateTime, DateTime offset, TimeOnly, and TimeSpan are what are called structures. There's many others as well, but these are the ones that you'll work with most often. In C#, to declare a variable, you specify the data type and then the variable name. So some examples would be int, product ID. So int is the data type, product ID is the name of the variable. String name, decimal, list price, date time, sell date. So these are all examples of declaring variables. Well, without further ado, let's now jump into that program.cs and let's start writing some code. So our first demo, declare variables. So here is that C# samples program that I created earlier. What I'm going to do is I'm going to wipe out the first couple ones, and we're going to start writing some C# code to declare variables. So the first variable type we'll look at is a character. I'm going to now assign to this variable that I created called rating the letter A. For character values, you must enclose the value you want to put into it in single quotes. Also, in C#, all lines must end with a semicolon. I can then do a console.writeLine. Now look at what Visual Studio has done for me. It does a console.writeLine rating, and it's kind of grayed out, but it says if you press tab, it will accept that. Isn't that neat? It really does a great job of anticipating our needs and what we're looking for. We've got a statement here ended by a semicolon, another statement here ended by a semicolon, and then another one ended by a semicolon. This is a declaration. This is an assignment. This is a class that's built into .NET called console. This is a method of that console class that knows how to display a value on the console. And then it reads the key, which means pause until we actually hit a key on the keyboard. So let's go ahead and run this. We can either click on this button here, we can go to debug and press start debugging, or we can press the F5 key to run this application. When I press F5, the console window appears and it displays our letter A. Next, let's look at the string data type. So I'm going to declare name as a string. For string, we use double quotes. And then we can still display that also on this console.WriteLine. The console.WriteLine will take any data type at all and display it on the console window. So let's go ahead and run this one. And there is our value. Next, we could do a Boolean data type. Maybe we give it a name like isActive equal to true, for example. And then again, we can display that on our console window. We'll press F5 and we'll see the value true appear. Next, let's do an integer. So we use the keyword int to declare our variable, and I'm going to give it a name of ID, and we'll set that ID value to a 1. So an integer is a whole number, so we just use a single digit here. And once again, we can display it using the console.WriteLine. Let's now do a decimal, for example. This one is a floating point type of number, so I'll maybe do price, and I'll do price equals $5.99, semicolon, and we'll display price. But we have a problem, and Visual Studio is giving us an error here by this little red squiggly we see. If we hover over that, it will give us an example of what's wrong and hopefully some idea of how to fix it. So in this case, it's telling us that the literal of type double cannot be implicitly converted to decimal. So when you use a floating point number, it assumes you're trying to use the double data type, but we've declared it as decimal. To force this floating point number to become a decimal, it says to use the M suffix to create a literal of this type. So we simply suffix those numbers with the letter M. If we now run this, we see the $5.99 appear. Now let's take a look at DateTime. This is one of those structure types. I'll call it cell date, and I'll set the cell date equal to, now, there is no delimiter. For characters, we had single quotes. For string, we had double quotes. And for numerics, it was just simply the numbers themselves. But there's no way to express or initialize a structure with any delimiter. So what I need to do is use another class. The DateTime class actually has some built-in methods, and one of them is called parse. So I want to actually parse 11/1/2022, and that will take that string, convert it to a DateTime. As long as it's in the correct format, it will convert it to this DateTime variable cell date. We can then display that on the console. Let's now use the DateOnly, and we'll call it end date. Now I've already got this DateTime.parse, but how do I create a DateOnly? Well, one of the things we can do is we can use the DateOnly class and use one of its methods. There is a parse. However, there's also another one called fromADateTime. So if we have a DateTime variable, Visual Studio picked it up and kind of wrote the thing for me. All I had to do was press tab, and now I can display both the cell date and the end date. Pressing F5, we now see both of them. When you're declaring variables, you can do multiple declarations on one line. For example, int product ID, comma, quantity makes both product ID and quantity integer variables. I'm going to recommend you always use separate lines for readability, because then you can optionally add a comment after each variable does. Now, it's not necessary, but I'll tell you, I hardly ever see multiple declarations on one line, so I would highly recommend you avoid it. Also, you can declare and assign in one step. So int product ID equals 1, and then, of course, you can add your comment. So if you do this and you avoid multiple declarations per line, I think you're going to find that your code is much more readable. So let's take a look at declaring and assigning values all in one shot. So I cleared out the program.cs, and now let's do some assignments and declarations all on one line. I'm going to create a byte variable called data. I'll create a short called index and set it equal to 2. I'll do a long called bin, and I'll set it to 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4. Now long can hold more values than an int. If I were to try to change this to an int here, this would give us a red squiggly that's saying that it can't do it. It's too long. So we need a long. I'm then going to use a float, which is another data type that can hold a decimal value. And again, we're going to get this little red squiggly because we need to suffix it with the letter F, just like we did with a decimal there. Then we'll do double cost is equal to 192. Now cost is fine because double is the implied value for any floating point number. Then all I need to do is a console.writeLine on data. And then look what happened. You see the little underline here that says the variable index is assigned, but its value is never used. Same thing with all of these, but as soon as I typed it in here, it went away on data. Look at this one. Now it's already figured out what I want. So if I do that, notice that the underline went away under index. Notice it now found weight, it found cost, and then it finally found bin. It didn't do them in the right order for some reason, so I'm going to go ahead and put them back into the correct order now, and then we can run this and we'll see all of those values displayed on the console. There's a special data type in C# called object. Now this is a very flexible data type in that it can hold any of the other data types. And you can even change the data type at runtime. This is not a good practice. You generally don't want to do this. In fact, you're going to find very few uses for object. You should find very few uses for object. Please don't use it unless you really have to. But it can store any data type and any value, including empty and null. Limit your usage of this data type. So let's take a look at an object data type and how it can change values from one to the other. So I'll type in object and then value. Now also notice the color coding that's going on here in Visual Studio. It tends to make things that are special in different colors. Kind of nice and very good for readability. So what I'm going to do is I'm going to make, first off, value equal to a numeric, like so. I'm then going to go ahead and write-line that out. Then I'm going to change it to a string. Remember, the double quotes means this is a string delimiter here. And then if I write this out again, we will see that it has indeed changed to a string. Wow, that's pretty neat. If you really want to see this, I'm going to give you a little bit of overview. If I go over here to the margin, you see this little circle that appears. That is for debugging. If I click there, it'll make that line that I'm on red. Then what I can do is I can start the debugging and it will pause on this line. And right now, value has a value of null. I'm going to press F10 to continue. And now we can see the value is 10. I'm now going to press F10. I'm now going to execute this line again by pressing F10. And now look, it's a string. You can see the quotes around it. So you see it actually changing the value on the fly. That is perfectly valid with an object data type, but no other data type can you do that with. So not a good practice, so try to stay away from the object data type whenever you can. Now what we saw there on the object data type is that the value already had a value of null. Well, why? Well, that's because each data type has a default value assigned to it. Numbers have a default value of 0. So if you don't assign anything to an integer variable, its default value is given as 0. String and the object data types are null. Date and time is given 110001. Boolean data types are given a false. So all you have to know is these few simple rules and you'll be able to always know what that default value is going to be. Well, let's take a look at assigning default values. Now all I have to do is say int id. And if I do a console.writeLine on that and we run this, whoa, we're getting an error. Why? Oh no, I thought you said there were default values. Well, Yes and no. So it's telling us that there's an unassigned local variable ID. You still have to give it some value. All right, now the reason why is there's something built in to .NET that prevents you from using this. That's the default now in .NET 6. And while you can override it, it's not a good practice. Instead, what you should do is give it a default. So there's a keyword default, and this tells the compiler what to do and what to assign to that variable, because you're saying, I don't know what it is right now. So go ahead and just give it the default. So isActive equals default. Now we have all of these. Let's go ahead and fill each one of these in. Now, since I ran that before and it came up with some errors, notice I have this error list down here at the bottom of the screen now, and it's telling me each of those little squigglies what's wrong. And you notice over there on the left, it has a little yellow triangle with an exclamation point. That's kind of a warning. And then the blue circle with an I in it means information. So if I start typing and I get things fixed, those errors actually go away, which is wonderful. That's exactly what we want to have happen. You can then close this at any time, and you don't have to have errors to display that. You can go to the View menu and choose Error List, and this will always then come up. You can turn informational messages off. You can turn the warnings off just by clicking on these little toggle buttons right here. I'm going to go ahead and turn that off for now. We'll go ahead and run this, and now we see all the default values for numbers, date time, and a Boolean. If we want to see the same thing for a string, string name equals default, and we display the name. Look at that. It's telling us you cannot convert a null literal or possible null value to a non-nullable type. Well, that's a bummer. But the reason why is because name is already null by default. So it's saying it's redundant for us to do this. Typically, what we would do with strings is you would assign them to a quote, quote, or you may also do string.Empty. So the string object has an empty constant on it. It'll take that, which is basically the same as double quotes. We can then run that and we see nothing because it's an empty string. Now by default, integers, decimals, date times, things like that cannot have a null in it, but each data type can hold null if you need it to. In order to do this, you simply add a question mark after that data type. So what this means is that we can then put either a null in or we can put data in. Now string and object are already nullable. However, starting with .NET 6 and higher, you can use the question mark, but there's really no reason to. All right, let's take a look at nullable types. So we'll start out with an int ID, but we're going to add the question mark now. And then you see what Visual Studio does. It tells you that you can now use the null. So we can do that, and that is now perfectly valid. So we could do a console.writeLine and ID, and we should see nothing because console.writeLine doesn't print out anything that is null. Now we could also say default on this as well. But when you do that, what do you think you're going to get? Are you going to get null or are you going to get a 0 because it's a numeric? Because you added the question mark, it's going to give it the null. And this works with all of them. So if I were to do decimal here, okay, it would do the same thing. If I were to do a date time here, okay, it will also do that. So nullable types, the default is always going to be null. So in this lesson, we saw that we can declare variables, and we should declare them one per line. We can assign values at the time of declaration, avoid using that object data type if possible, and you can now take advantage of these nullable types if appropriate. You don't always need to use them, but sometimes they do come in handy. Next up, math, comparison, and logical operators.